Class 7, Sacred Heart Senior Secondary School, BRS Nagar. Science, Lesson 15, Light. An effort by Hanor Kaur, Class 7, Pink. For tuitions, please call 9815444985. Light. Light is a form of energy. Light is needed to see things around us. Light enables us to see objects from which it comes or from which it is reflected. We detect light with our eyes. Light travels in straight lines. There are a number of everyday phenomena which suggest that light travels in straight lines. 1. Formation of day and night suggests that light travels in straight lines. If this were not so, then light would have curved around the earth and there would have been sunlight during night too. 2. Formation of shadows suggests that light travels in straight lines. 3. When a beam of sunlight enters a dark room through a ventilator, we can see the light traveling in a straight line. 4. When the headlight of a car is switched on, the light rays appear to travel in straight lines. 5. If we almost close our eyes and look at the burning candle flame, it appears as if it is giving out a few beams of light, which are traveling in straight lines. 6. Beams of searchlight used in a lighthouse or airport suggest that light travels in straight lines. 7. Beams of light coming from the projection room in the cinema hall suggest that light travels in straight lines. 8. The light coming from small laser torches used as pointers suggests that light travels in straight lines. The property of light traveling in a straight line is called rectilinear propagation of light. The path of light changes when it falls on a mirror or any other polished and shining surface. Thus, a mirror changes the direction of light that falls on it. This change in direction of light by a mirror is called reflection of light. After reflection also, the light continues to travel in a straight line path. When a ray of light, while traveling from one optical medium to another optical medium, strikes the surface of separation of two media, the following situations can arise. The ray of light may be returned by the second optical medium into the first optical medium with a change in angle. This phenomenon is called reflection of light. 2. The ray of light may get absorbed by the medium. 3. The ray may pass through the second optical medium with a change in the angle. This phenomenon is called refraction of light. All these phenomena can take place at the same time, that is, a part of light energy can get reflected, a part absorbed and a part refracted. Reflection of light. When light falls on the surface of an object, the object sends the light back. The process of sending back the rays of light which fall on the surface of an object is called reflection of light. The ray of light which falls on an object, say, a mirror, is called incident ray. And the ray of light which is sent back by an object, like a mirror, is called reflected ray. It is not only a mirror which reflects light. Most of the objects reflect light which falls on them. Some objects reflect more light, whereas other objects reflect less light. The objects having polished, shining surfaces reflect more light than objects having unpolished, dull surfaces. For example, a shining silvered mirror, ordinary mirror, reflects back almost all the light which falls on it. In fact, any polished and shining surface can act as a mirror by reflecting most of the light. There are two types of images that can be formed with light: real images and virtual images. 1. Real image. The image which can be obtained on a screen is called a real image. For example, in a cinema hall, we see the images of actors and actresses on the screen. So, the image formed on a cinema screen is an example of real image. The image formed in a pinhole camera is also real image because it can be received on a screen. A real image is formed when light rays coming from an object actually meet at a point after reflection from the mirror. A real image can be formed on a screen because light rays actually pass through it. 2. Virtual image. The image which cannot be obtained on a screen is called a virtual image. A virtual image can be seen only by looking into a mirror. The image of our body formed by a plane mirror cannot be received on a screen. It can be seen only by looking into the mirror. So, our image in a plane mirror is an example of virtual image. The virtual image is just an illusion. So, virtual images are also called unreal images. A virtual image is formed when light rays coming from an object appear to meet after reflection from the mirror. It is not possible to obtain a virtual image on the screen because light rays actually do not pass through it. Mirror. A mirror is an object that reflects an image. Light that bounces off a mirror will show an image of whatever is in front of it. Types of mirror. 1. Plane mirror. A plane mirror is a mirror with a flat, planar, reflective surface. Characteristics of plane mirror. 1. The image formed in a plane mirror is behind the mirror. 2. The image formed in a plane mirror is virtual, means it cannot be obtained on a screen. 3. The image in a plane mirror is of the same size as the object. 4. The image in a plane mirror is erect. 5. The image formed in a plane mirror is at the same distance behind the mirror as the object is in front of it. 6. The image in a plane mirror is laterally inverted, sideways reversed, with respect to the object. 2. Curved mirror. The common example of a curved mirror is a spherical mirror. A spherical mirror is that mirror whose reflecting surface is the part of a hollow sphere of glass. The spherical mirrors are of two types of spherical mirrors, concave and convex. 1. Concave mirror. A concave mirror is that spherical mirror in which the reflection of light takes place at the concave surface or bent-in surface. Uses of concave mirrors. 1. Concave mirrors are used as shaving mirrors to see a large image of the face. 2. Concave mirrors are used by dentists to see the large images of teeth of patients. 3. Concave mirrors are used as reflectors in torches, headlights of vehicles. 4. Doctors use concave mirror reflectors to produce a parallel beam of light for examining the body parts such as eyes, ears, nose and throat. 5. Concave mirror-shaped dishes of dish antennas are used to receive TV signals from satellites. 2. Convex mirror. A convex mirror is that spherical mirror in which the reflection of light takes place at the convex surface, bulging out surface. Uses of convex mirrors. 1. Convex mirrors are used as rear-view mirrors or side-view mirrors in vehicles. 2. Big convex mirrors are used as shop security mirrors. The front side of a shining steel spoon is a concave mirror, whereas its back side is a convex mirror. Why are concave and convex mirrors called spherical mirrors? Concave mirror and convex mirror are called spherical mirrors because they can be considered to be small parts of a hollow sphere of glass. When the rays of light come closer, we say that the rays of light are converging. The concave mirror reflects the parallel rays of light in such a way that, after reflection, all the rays converge or meet at one point called focus in front of the mirror. The focus of a concave mirror is a point in front of the mirror at which parallel rays of light converge after reflection from the concave mirror. Focus, also called principal focus, is denoted by the letter F. The distance from the focus up to the concave mirror is called focal length of concave mirror. The focal length is denoted by the letter F. The focus of a concave mirror is in front of it. The focus of a concave mirror is real because light rays actually pass through it. Since a concave mirror converges a beam of parallel light rays, therefore, a concave mirror is also known as a converging mirror. When the parallel rays of light spread out, we say that the rays of light are diverging. A beam of parallel light rays diverges, spreads out, after reflection from a convex mirror. Since the parallel rays of light diverge, spread out, they cannot meet at a point in front of the convex mirror, but they appear to be coming, or spreading, from a single point F behind the convex mirror. The point F is called focus of convex mirror. The focus of a convex mirror is a point behind the mirror from which the parallel rays of light falling on convex mirror appear to diverge after reflection from convex mirror. The distance from focus up to the convex mirror is called focal length of convex mirror. The focus of a convex mirror is behind it. The focus of a convex mirror is virtual because light rays do not actually pass through it. Since a convex mirror diverges a parallel beam of light rays, therefore, a convex mirror is known as a diverging mirror. Spherical lenses. A lens is a piece of transparent glass bound by two spherical surfaces. Lenses play a very important role in our everyday life. The magnifying glass, which is used to see very small things clearly, is a type of lens. Lenses are used in making spectacles, cameras, microscopes, telescopes, film projectors and binoculars, etc. Lenses are of two types. 1. Convex lens. 2. Concave lens. 1. Convex lens. The lens which is thicker in the middle than at the edges is called a convex lens. The focus F of a convex lens is a point where parallel rays of light converge after passing through the convex lens. The distance from focus up to the center of convex lens is called focal length of convex lens. Since a convex lens converges light rays falling on it, therefore, it is also called a converging lens. The nature and size of the image formed by a convex lens depends on the distance of the object from the convex lens. A convex lens can form real and inverted image. When the object is placed very close to the lens, the image formed is virtual, erect and magnified. When an object is placed at a far-off distance from a convex lens, the image formed by convex lens is real, inverted, and much smaller than the object, or highly diminished. When used to see objects magnified, the convex lens is called a magnifying glass. Uses of convex lenses. 1. Convex lenses are used as magnifying glasses. 2. Convex lenses are used in making spectacles, cameras, microscopes, telescopes and binoculars, etc. 2. Concave lens. The lens which is thinner in the middle than at the edges is called a concave lens. The focus F of a concave lens is a point from which the parallel rays of light appear to diverge after passing through the concave lens. The distance from focus up to the center of concave lens is called focal length of concave lens. Since a concave lens diverges light rays falling on it, therefore, it is also called a diverging lens. Whether an object is placed at a large distance or it is close to the concave lens, a concave lens always forms an image which is virtual, erect and smaller than the object. Uses of concave lenses. 1. Concave lenses are used in making spectacles. 2. Concave lenses are used in making certain kinds of telescopes. 3. Concave lenses are used in the peepholes in the doors of hotel rooms to see the image of the person standing outside. Dispersion of light. In the year 1665, Newton discovered by his experiments with glass prisms that white light consists of a mixture of lights of 7 colors. Newton found that if a beam of white light is passed through a glass prism, then the white light splits to form a band of 7 colors on a white screen. The band of 7 colors formed on a white screen, when a beam of white light is passed through a glass prism, is called spectrum of white light. The 7 colors of the spectrum are red, orange, yellow, green, blue, indigo and violet. The splitting up of white light into 7 colors on passing through a transparent medium like a glass prism is called dispersion of light.